Hello everybody. English people, excuse my English. So what we'll show today, a simple case study where we weren't able to implement continuous delivery setup. So we found another way to keep things on the good track. So we will start to ask who fears continuous delivery, and we will present our simple pattern that is test-driven deployment. We will show our case study from writing the test, from switching from the test to the setup, and then to contribute part of the code we developed to the community. I am Roberto Polli, and I'm a solution architect at Partech. I love writing code, and I've got a couple of Red Hat certification. I thank the company where I work, which is sponsoring this talk and my travel. So the question, who fears continuous delivery? There are many infrastructures which are legacy. They have to be compliant with laws and regulation. They use old software and libraries, and they are intrinsically resilient to new technologies. Those are enterprise infrastructure with a slow release cycle, heterogeneous environments with Linux and old operation system, just like Sun Solaris, EAX, and their maintenance involves different IT departments. So if an IT departments have to do something, they should ask for permission to other one. And shortly, those environments are working smoothly since Java 1.2. So why change? Well, why change and not adding a bunch of new technologies requiring Go, Ruby gems, and Python 2.7, which was not even in the mind when the infrastructure was deployed, and add external repositories that might require new licenses, even if it's open source, because if you're in an enterprise environment, you have to buy a subscription of your Linux distribution. You should ask for permission to the Network Operations Center to open and download new software. You should ask for the Security Operations Center because you are introducing new software. So you may need, for example, if you have the Puppet server, you should review your upgrade policy. You should ask for new network rules on your firewall and your load balancer, and you should add audit of new services because, hey, if you add a Puppet server, then you have to ask, and there is a team that should make a security assessment on your Puppet server, and so on. Switch to continuous delivery is hard because customers, enterprise customers, are reluctant to disruptive changes when their infrastructure is working since Java 1.2. And operation teams should adapt to new technologies. You should talk to your customer, you should explain to your customer, but you should talk to their support teams. And it's not always easy. But if you use a test-driven deployment approach that we will describe it soon, and Python, you are just proposing, hey, why we just don't start with testing? And if you say testing, people think, hey, they're just adding tests. We like tests. We want tests. And testing is not disruptive. And probably with the management, you just don't speak about Python, okay? You speak about Python with the operation team, and you say, hey, you don't know it, but it's just installed on your Linux system and in many Solaris environments because it's used during the installation phase. Moreover, you can introduce ipython because ipython shouldn't necessarily be installed on the servers, but on the workstation of operation team. It has share compatibility. So there is a ipython parameter which says if what you run is not an ipython function, is not a Python module, just run it from bash. So if you type ls, okay, you get the ls command. If you use a lot of bash commands which have now Python naming conflicts, you are just telling them, use this, and it's a bash on steroids, and it has self-completion. So if you have to check something that you don't know, you get self-completion for Python libraries. So what is test-driven deployment? It's just like write down your infrastructure requirements, create tests for each requirement, many tests for each requirement. You can test configuration. So did I write the right rules on my network configuration, on my LDAP configuration, my MySQL configuration? And I can test the behavior of the configuration. And then I will start to set up the infrastructure. That is, in many cases, just run test. So the old setup just have all greens, and new setups have all red. And then run and reuse part of the work I've done for the testing and deployment part to monitor on nudges or other monitoring mechanism. And I can, in this way, monitor if everything is fine, but I can monitor too configuration changes. If somebody changes the configuration, even if this doesn't cause issues on the setup, I get an alarm. Hey, somebody changes the configuration. What's happening there? Is it fine or not? Because monitoring stuff is probably done by another team respect to the operation team. So why Python? Because it's already installed on all Linux servers and on many Solaris servers. We have batteries included because POP, SMTP, IMAP, HTTP, Telnet are built in. Modules, if they are not in the standard library, are probably in the distribution repositories which are already added in the customer repository, so they don't have to buy subscription of new stuff. They just have to install something which is in their infrastructure. If there are modules which are not installed, I can package them as zip files. So just add a zip in a operation directory, and it's fine. It's interactive. If I have to do something, I can, if I don't have a Python, just vanilla Python supports readline capabilities, but I have to just import readline and set tab completion complete. Shortly, no external repository, no policy changes, no external teams involved. I just speak with operation team. So, our case study. What did we want to do? We want to eliminate maintenance issues. Well, our customer had an infrastructure with many maintenance issues. They called us almost once a week because something happened on our servers. And we took the opportunity of a major upgrade to tell them, okay, let's put it on the right side. We spoke with their operation team, and they said, okay, we wanted to do it. We wanted to identify issues and their effect on the platform. So when there was an issue, we want to let people know which were the effects on the platform. So we had started with database setup used by many applications, and in what we did, we made explicit every problem on the infrastructure, which was the symptoms for the end user, and to document with code. We used Python LDAP module, and we used a set of bug fix script from the 389 team. 389 is the LDAP directory server that we use to implement our infrastructure. It's open source. It's the upstream of the Red Hat directory server. And the advantage of this solution is that we had a small footprint on the infrastructure. So next slide is the infrastructure layout. If you are not used to LDAP, it's fine. You are not required to understand how the infrastructure works. It's just to show you that it's not so easy. It can be tricky to test everything. There are many clusters and a proxy set up with a management interface, which is the red line. And there are external services that use all the clusters. It's about 30 LDAP server when we left it. Now I think they added something. They use replication and proxy topologies. And there were different people involved in the management. That means that if today I've got John, Mark, and Frank working on that, tomorrow maybe I have John, Andrew, and Thomas working on that. There is not always the same people working on this infrastructure. There are different databases with different properties. There were a lot of things to monitor. And so we collect all the LDAP-related platform requirements. So, for example, password should expire periodically. There were fine-grained access control lists, so some user could do something, other user couldn't. And there should be replication. Replication is made with users that are not the same as platform user and are not the same as admin user. So every kind of user should have different privileges. We tested connectivity routes, what was admitted and what was not. For example, ping from, for example, if I have to connect from this host to this other one, I should route from the given gateways and not from the other one. A lot of infrastructure requirements. Then, for every single requirement, we write down tests. For example, in every test, we explicited symptoms on the infrastructure. That is, if this test fails, user cannot change password. If this test fails, replication may not happen. So it's a lot of tests and a lot of symptoms for each test. The configuration should be human readable, because if tomorrow Thomas, the newcomer, should run the test and see that something was not working, he should have clear what wasn't working, which are the symptoms on the real infrastructure. For example, user might not change password from the web interface, and if they add new hosts, he should be able to change the topology, run, and check that everything is fine. How we do it? It's with Nose. Nose is a Python framework which makes tests easy. Nose runs every file and every function starting with test. So I just say to the newcomer, Thomas, okay, there is a problem, you don't know anything. Go to this directory, just run nose test -v and wait for all tests to complete. If there is something that is not working, then start from there. Moreover, it's easy to filter tests. Just use -m. So if I suspect there is an issue on replication, nose test -v, name of the test file, -m replication, and I will just run only replication issues, test cases. In nose, every function is a test. So it's really easy to add new tests. I don't have to extend classes. I don't have to teach people object-oriented programming. They just have to write a simple function. Many operation team, in many cases, maybe people that starts in late 90s doesn't know object-oriented programming and started from Perl, started from Bash. We should let people work and teach them. We cannot just throw them a bucket of new paradigms because they wanted to learn, but we should let them do. In this case, we are watching 3 functions which testing password policies. There are not 3, there are many more, but the more we test, the more we are confident that stuff works. Moreover, for every test, I've got a single line in the configuration of our environment. So when we have many servers, to be explicit, it's really useful. If you are to run tests on 30 servers, you just cannot think, okay, they can guess what's happening. We let them, we guide them. Moreover, document with code. We describe the infrastructure with dictionaries. This is really easy. Replication topology. Backend 5 should replicate to 9 and 10, frontend 9 and 10. Backend 6 should replicate to 9 and 10. Backend 7 should replicate on 9 and 10. This is a bit verbose, but it is clear and it is flexible. So this is maybe the most trickiest slide. Right, for readability, keep tests simple. We have just one test. Has replica, master slave. Test if the master is configured to replicate to a given slave. Okay, this is simple, this is usable, this is runnable from the command line using an interactive interpreter. I can have other tests which checks if the master is actually replicating. So 2 different tests, one for configuration, one for operation. Okay? Then, once I've got this kind of test, I can start using my framework. Use an easy framework, Nose is simple. My test has replica. What does it do? Just run this test for every master and slaves in my replication topology. So get my configuration and gives a bit of automation of that. The advantage of Nose with this yield feature is that if I write this kind of code, then Nose doesn't run one test. It runs, for example, 3, actually n tests. For every case, for every couple, I've got a single test. Okay, fail, okay. In this case, it's really easy, even for newcomers, to check where could be the issues. Because if I got the right configuration, but I've got an error on the replication status, then I can contact the right people to check, for example, for connectivity. Even if those test cases includes connectivity checking, for example, running the IP root suite on the machine, because with Python I can run bash commands, and I can get if machine pings between themselves, if machine have their correct root sets. Writing tests, explicit is better than implicit. On the left side, we have a well-written test. This sets a configuration of a backend and tests if the configuration is fine. There is an explicit of names, and everybody can understand what is it doing. A database should have a gigabyte of cache size. Another one should have a 1 megabyte of tests of cache size. On the right side, there is something that is almost unreadable. One is not a host name, so I should recur to some pattern function to reformat my host name. And this function will pollute my test code. This is test code pollution. And not everybody knows byte shifting in the real world. So if I am lucky, something will just open a shell and type the computation. If I am unlucky, well, it's just like I don't know what it is. I will open a support call to me. I didn't want it. Didn't want this. So clarity versus the operation team. Don't pollute the code. Using this case, I can just use getFQDN on my host. And moreover, I can add hosts for other domains. If I add a disaster recovery, I just add a line like this in my topology, and I'm fine. If I don't, well, I'm troubled. I should rewrite all my tests and refactor everything just to add a single new domain, because probably I can just add another parameter. So I modify my function to be has replica host comma domain. It's not clear. So write for usability, because when we improved the library we started work with, we wrote the tests, get feedback from the operation team, exchange the code from the 3 and 9 team. So we get something which is reusable and in the roadmap of a product, not just I have to write tests, it's boring, let's do it as fast as possible. The code evolved. We moved the infrastructure test code to the library. So we removed duplicate code and improved the user experience, thanks from the feedback of the operation team. Moreover, the infrastructure tests were used to test the library. So we used the code from platform tests, and we had platform tests becoming very dry, because the replica method comes from the infrastructure test to the unit test of the library creating the tests. Just some example code. The operation team learned Python via auto-completion and test code. Test code was focused on interactive use. Mnemonical names and docstrings were essential. And moreover, logging. When they type the command to check, for example, if the master has replica. They got the logs and the trace, just like you can have with HTTP request and response. So they don't need it to tail on the log on the LDAP server. This was really important. The connection was happening with URIs and checking, for example, which are the backend lists. So all the LDAP databases on a single server were easier than using bash. So they were routed to use the library instead of using their old method that were prone to errors and typing a lot of code. Then, from test to setup, when all the tests were fine, we added new servers with a new version of the LDAP server. And as we had all the test code, we just started to create the deployment code. So instead of making search on the server, we added new entries. The create backends, get the backends from the topology we were going to test and create, provision new servers. That was very easy. The logging enabled us to produce an installation logs. We reused the infrastructure test, as I said, as functional tests on the setup code. So setup code was very easy to produce because in the setup environment, on developing environment, we just have to spawn some server, run the code, and reuse the test we had to write the function. And then with this new shiny library, we can use Ansible on new project. Shortly, the story of the library. We started from Rich Magginson scripts. Rich is the 3.9 team leader. We wrote some Python scripts to test his infrastructure. I got it. I wrote a DSadmin library with all those tests. Then speaking with Rich, he says, hey, but you made a great job for us, and take all the bunch of the modification. And all this became the lib389, which is now delivered in Red Hat Directory Server. It's not, it has not the same approach because the library, the 389 library is focused on testing environment, while DSadmin has a focus on deploying new instances. But as soon as I've got some time, we are in touch to make everything on the same track. This is what happens to the code. Starting from Rich's library, a lot of test code. Part of the test code moved to the library. Less test code. Part of the test code moved to unit test. Test code is very dry. Many code moved to the library and to the unit test. So continuous delivery is good, but it's not welcome everywhere. Test-driven deployment in Python is a viable solution. Use ipython and nose. Write tests starting from requirements, from document requirements and map, and write in the document docstring, in the test docstring, the reference to the platform requirements. This will speed up and ease your work. Then update, deploy, write for usability, readability, and reusability. Thank you. That's all, folks.
Thank you.
Question, because we have to hurry to take the coffee, but I am for you if you have more questions even after everything is ended.
Actually, we have a bit of time for questions. So basically,
thank you for this talk. Maybe you mentioned this, but I didn't get it from your talk. How did you organize the code? I mean, you have part of the code that runs on operations team workstations and part on the servers, or everything runs on workstations and connects to the servers remotely?
That depends. Part of the code can be run, all the code can be run just from a workstation which has access to the machine IP layer. So you should be in a good position in the network. Some tests can only be run on the machine. For example, the one checking if the routing is fine. So you can check replication, you can check almost all the LDAP stuff from remotely, but the code which tests if the network is fine, if the host configuration is fine, if the other parts are fine, should be run directly on the machine.
Other questions? So, thank you, Roberto.
Thank you for listening.